Okay, Algebra 1 students, here are the 4 problems that were posted on Edmodo for solving equations. Now, this first equation is a single variable equation. In other words, we only have this n as our variable. So as far as solving, we just got to isolate or get that n by itself. So we need to think about undoing all the other operations. So the only thing that really makes this equation a little bit more difficult is the fact that we have all these fractions. So I always just think of these fraction bars instead as division. So really I want to undo this division of 3. I undo division with multiplication. And whenever I do something to an equation, I have to do it to everything in the equation. So I'm going to multiply 4/3, and this is a product of 3 terms right here, so I can take the product anyway, so I'm just going to take it to here, which will make 3/3, or 12/3, which is just 4. And I'm left with 1/2 plus n equals 3. To this side of the equation, again, will leave me with 3/3 makes 1. 1 times 4 is 4. So I undo that division using multiplication. Now with this 4, I'm just going to distribute, or I could divide by 4. There's different ways we could approach this. Let's say I do this. Half of 4 is 2. 4 times n is 4n equals 4. Subtract 2, and I'm left with 4n equals 2. Divide by 4 or multiply by 1/4. 2 divided by 4 is 1/2. Okay, second one, solve a system. Now you should recognize that each of these equations has 2 variables. So we think about this in terms of the graph. These are 2 linear equations. 2 linear equations either intersect at one point, never intersect, or are the same line. So those 3 scenarios are the solution to the system. I'm not going to use the graph. I'm going to use an algebraic method. I'm going to eliminate one of these variables. So when I look at these, 10 and 3, then I look at 2 and 8. I already have opposite signs, so I can real easily make this into an 8 by multiplying this whole equation by 4. So I'm going to rewrite the top one because I'm not changing that. I'm going to rewrite the second one, but it's going to be 4 times larger. So 12x minus 8y equals negative 24. Now this is what I wanted, because this makes 0, which eliminates that variable from the result when I add these 2 equations together. This will give me 2x equals 4, and that will give me x equals 2 as a solution. Well, remember, the solution is an ordered pair, which has both an x and a y. So I take the solution for x, plug it into either equation, but I always go back to the original, and I solve that for y, and I end up with, let's see, negative 2y equals negative 12, so y equals 6. So these 2 lines, if I graph them, would intersect at the ordered pair 2, 6. Or these, this set of 2 numbers for x and y would make both of those equations true. Okay, number 3, this is a proportion. See that single fraction equal to another single fraction. And the easiest way to solve one like this is to basically multiply this side by 3 and this side by 4. So I end up with 3 which would be 3n minus 15 equals 4n minus 28. Now I can isolate get my n's together. I'm left with negative 15. And I add 28. I get n equals 13. Okay, last one. This equation has an exponent of 2. It's a quadratic. So when I think about ways to solve a quadratic, I have factoring or the quadratic formula. either would work as long as it's factorable. So I always try that first. So I'm going to get them all on one side. It only works when I have my equation equal to 0. Same with the quadratic formula. So now when I look at this, I'm trying to figure out if I have, when I rewrite this as a product, p times p gives me that p squared. Since this is negative and that's positive, I know I got to have opposite signs here. And I know that 8 times 4 is 32, and I could get 4 out of that. Since this is positive, I want the larger number to be positive. That's my factorization. So you have p squared plus 8p minus 4p does give me positive 4p in the middle. Gives me that last term of negative 32. So now I split. And I get the solutions p equals 4 and p equals negative 8.